Hey students, this is your notes video for lesson 9.4, choosing a data display. So first we have several different types of data displays here. We're going to match each type of graph with what it's used for. And I'm going to go through the right-hand column and we'll read the description and then see if we can find the graph that matches. So showing data using pictures. Think for a minute about which one that would be. That is a pictograph. Okay, showing data in specific categories. That sounds like a bar graph to me, right? We're comparing specific categories and how many of each category there are. Okay, shows data as parts of a whole. That's a circle graph. The circle is 100% or the whole, and we're seeing which categories make up each part of the whole. Showing how data changes over time, that's a line graph. That line shows us whether it's trending up or trending down and how that changes over time. Frequencies of data values in intervals of the same size, that is a histogram. We put each of our data values into a group. Each of those groups needs to be the same size, and then we see how many data values fall into each group. Okay, orders numerical data and shows how they are distributed. All right, I'm thinking that's stem and leaf plot, but let's come back to that one. That one's not quite as obvious. All right, showing the variability of data set using quartiles. That is a box and whisker plot, where we see the first quartile in the first whisker, the second and third quartile are the box, and then the fourth quartile is that second whisker. Okay, showing the number of times each value occurs in a data set. Okay, let's come back to that one. Showing the relationship between two data sets by using ordered pairs in a coordinate plane. That is a scatter plot. Okay, so we're left with stem and leaf plot and dot plot. Those are really similar types of graphs, actually. The dot plot is kind of like a stem and leaf plot on its side. So let's read again and see which one goes with which. All right, so I think the ordering numerical data, that goes with that stem and leaf graph. We put them in a particular order, like 10, 12, 13, and 16 would be the first four in that little example. And then the dot plot is this last one. Okay, so we have matched those different graphs. Next, we're going to choose an appropriate data display for a situation. So we have the number of students in marching band each year. Okay, so the line graph was showing how data changes over time. So I think a line graph would be a really good one. Change over time. Okay, and then the second one is comparison of people's shoe sizes and their heights. So this sounds like a perfect scatter plot because it's showing the relationship between data sets. So it would be the relationship, right, data sets. In this case, it would be showing the relationship between shoe size and height, which I would think would have a positive correlation, but probably not perfectly correlated. You might have somebody that has big feet and that is kind of on the shorter side, or a taller person that has smaller feet. It wouldn't be a perfect correlation, but it would be some sort of a positive correlation probably. All right, next, we're going to identify an appropriate data display. So it says you record the number of hits for your school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits changed during the 5 months. Okay, so first we have a bar graph, and we can see exactly how many hits were on the school website each month. We can kind of see that it's getting bigger each month as more people are hearing about the website. So I would say this is yes. It shows how many hits were on the website each month. All right, next we have a histogram, and we can see, there were 2 months that had a number of hits somewhere between 0 and 399. There were 2 months that had between 400 and 799 hits, and there was 1 month with between 800 and 1,199 hits. I don't know about you, but I can't tell anything from looking at this. I don't know how many hits there were each month. I don't know which month was between 0 and 399. I would kind of like to know whether it was 0 or 399 also. That's a pretty big range. So doesn't give relevant data here or relevant information. Okay, so that one does not work. And then let's look at the third one. This is a line graph. And I would say, yeah, this one is, line graphs and bar graphs are pretty similar. We can kind of see this positive trend in the bar graph. We can see it even more clearly in the line graph. It shows change over time. So the bar graph or the line graph are fine. The histogram is not a very good one. All right, next in our third example, we're going to look at which line graph is misleading. So here we have box office revenue over time, and we see, ooh, we have this huge jump here from 2005 to 2009, and then it kind of stays high. But then when I look at the second one, I see, you know what, it really wasn't that huge of a jump after all. Here's the problem. This little broken axis gives us the impression that there was more change over time, but there really wasn't. So graph 1 is misleading. Growth was not that much. Okay. And our last one, we're going to analyze a misleading data display. It says a volunteer concludes that the numbers of cans and food and boxes of food donated were about the same. So we can see that these two rows kind of end up in about the same place, a little bit more cans, but about the same. Is this conclusion accurate? So let's see here. Each little picture of a can in our pictograph is worth 20 cans. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cans. So 11 times 20, that's 220 cans. And each picture of cereal is also worth 20. 1, 2, 3, 4, 5, 6. Ooh, 6 times 20. That's only 120 boxes of food. And the bottles, we have 20 plus 20 plus 10, that's 50. So I would say no, this conclusion is not accurate. The picture of the box is bigger, so it looks the same, but it is not. We collected quite a few more cans than boxes of food. Okay, go ahead and try the on your own, and I'll see you soon.